tackle the representation of this crucial, very difficult relationship to represent, and that is the many-to-many relationship. Because when you have many-to-many relationships, you have proliferation of tables, linking tables, and you get these large schema that are difficult for end users to understand, and it rapidly becomes impossible for them to query them. And so the question is, how is it best to represent them? So the first thing that I've said is, in terms of how we represent many-to-many relationships, is the star itself. So I want you to remind yourself that the relationships, when we have something like an order fact table with day, product, salesperson, customer, that those are all, one day can have many orders, one product can have many orders. Therefore, the relationship between day and product is a many-to-many relationship. So the center of the star is the linking table for all of the many-to-many relationships. So that is the core way that we're representing many-to-many relationships. Is anybody unclear about why I'm saying that the fact table is how we're representing many-to-many relationships? Remember that we have the compound key, and now we have a multiple compound key for all of those foreign keys that are in there. Okay, so this is the curious solution that we have for this, and it's called a bridge table. And so we're having a many-to-many relationship with the actual fact table here. Or at least that's what it looks like here. Is we have the sales rep over here, we have a linking table in between, and we have the sales fact table on the other side of the relationship. And so the question is, can we allow that? So let's ask if this is that we essentially what we're doing is we are creating a table that really looks like this. So ordinarily this would be sales group K would be a PK, FK. Then this would be a PK, right? Because all of our dimensions only have a table in them that has a primary key. This is the primary key here. And then these two keys here are primary keys and foreign keys. Sorry, so this is, I've got this right now in this particular one here, right? Dimension only has a primary key. Primary key is going into the order fact table. So this is where the linking table is, the so-called group membership. This says that a sales group can have more than one member in it, and the sales can be, a person can be part of a sales group. And so we have a linking table in between them. And so this is the solution that, and I tell myself each year I do this, I probably should start with this slide first. This slide makes a little bit more sense here for the way that this is actually working. Okay, so then the question is, why not have 3 tables like this rather than the 2 tables that I just showed you in the prior slide? And so what's happening in this prior slide is that we're simply eliminating the linking table and moving the key of the linking table into the sales group table here. So the solution collapses the left-hand side of the many-to-many relationship into the sales group, avoiding one join. And so you kind of have to follow what's going on here. We're going to take this, see how we have the sales group key here, and we have the sales rep key here. And what we need to have is we need to have this many-to-many relationship to have those 2 keys together. So we're just moving this key up into this table here and getting rid of that table. So that's what's called a bridge table for the implementation of a many-to-many relationship problem here. So I'm going to attempt here to have it in Excel here so that we can look at the problem simultaneously and make our design simultaneously. But I'm going to make that a little bit smaller over here and then see if I can put the design over here. So let's, somebody tell me what dimensions you created so far. So what dimensions did we decide we needed? Okay, go ahead.
You need student.
A student dimension, okay. All right, so we're going to say that with that we need a student ID, and we'll call that the key field there, okay. What other dimensions do we create? How about back here? A team dimension, okay. A team dimension, and so we need a team ID for that. Call that a primary key. And in the student dimension, let's assume that we need a student name for that, okay. All right, what other dimensions do we need? How about over here, Nawaf? An exercise dimension, so something about the assignment, okay, I'll call that the assignment dimension, and have an assignment ID with a primary key, and let's say analytics type, just to give this some flavor. So keep track of what analytics type was being discussed on that particular assignment. Okay, any other dimensions? Noah? A date, thank you. Now that's the thing, is that in any of these assignments you can almost never go wrong if you start off by writing down the words date dimension.
Even if an assignment's given per day?
Well, what do you mean per, why? Is this, the granularity is per day?
Okay.
Well, then we need to say what day it's for, right? If the granularity is per day.
Yeah.
So if we don't have a date dimension, what it means is that whatever measures we have in the fact table have been aggregated up to the total for the entire time period that we are covering, right? So it's very rare that we would ever want to do that. All right, so we have these 4 dimensions. Now, the big crucial question we have here is, what is the fact table going to consist of? So what is the level of granularity do we need for our fact table? So various groups here probably had some ideas, so I'm going to pick on the middle group. What did you choose for your granularity for the fact table? Did you reach a decision? What were your choices?
We did teams as a bridge between students and fact.
But what was in your fact table?
We didn't really break down the fact table yet. We had teams and date, and we were working with how to fit assignment.
So how can you actually have a bridge, say that you know that you need a bridge table if you don't know what's in the fact table? That's kind of making an assumption, putting cart before horse, possibly. How about in the back? What did you have for your fact table? A score? Okay, and the score of what, though? Of the team, of how the team did. So let's take that idea and let's run with that. Let's say that this is going to be the team score fact table, okay? So if that's the case, then we're going to have in this, we're going to have our team ID, and we're going to have our assignment, oops, sorry, I should have been copying that. Team ID, we're going to have our assignment ID, and we're going to have our date ID, and we're going to have the team score. Okay. Okay, so how do we bring the individual student into the picture? As we still have the student dim here. I'm going to actually move the team dim over here. That's kind of a hint. I'll also try to make this, oh, sorry. All I wanted to do was move this up a little bit, make that a little bit bigger. Sorry, they don't teach good Excel skills in graduate school. Okay, I'm gonna kill this completely over here. There. All right, so what do we need in order to bring students into the picture? Oh, sorry, Jason.
So you use, from the fact, you use team as a bridge to student, so you take the primary key from student and put it into the team dimension.
Let's see. Okay, so you're going to use, we're going to put the student dim over here then, and we're going to say put the student ID here, and make that into a PK FK. So narrate for us what we've actually, how this represents students being a part of a team.
You would know which individual student was part of what team. Because
Oh, Nawaf?
We have just one student in the team then.
because you can have a record from them.
We have team ID and student ID as a compound key, right, in our bridge table, right? And so over here we have the team ID with the score. And so the only thing I haven't fixed is I actually need to make this, put these as foreign keys here, right? FK also. Assignment ID is FK. And then the date ID is the FK. So again, why does this work? We have our entire list of students. On any given date, we're creating a set of teams. So how are we going to create the set of teams? We're going to do that by making a combination of a team ID and a student ID. Then we're going to put the team ID and the score fact along with the assignment and the date. So on a given date, a given team gets a given score. So this gives us the ability to know the score of every team for every assignment and the composition of every team. So the only problem that we have to figure out is how are we going to give the team bonus to the team lead? Give the bonus to the team lead. Jake?
I'm not so sure anymore, but I'm going to still say it. Would we put yes or no for team leader in the student dimension?
Well, if we did that, how would we handle the fact that the team lead changes hands depending on which team they're on?
We'd have to adjust more than one record, right?
Well, we couldn't adjust that, right? If we're going to have a static list of students in the student dimension, somebody cannot simultaneously be a team lead and not a team lead, depending on which week they're on. Jason?
I have a question. Can you put, I'm assuming you can put attributes in the team dimension. So
In the team? Yes, you can.
So
Mhm.
you could put team lead,
Mhm.
yes or no as a boolean
Mhm.
there. And you could also put absent in there too, students absent.
So that gives us a means then of adjusting the student score. Jake?
Is team lead going to be the ID of the student?
Well, so just think about what the data is in there, okay? So the student, the student's ID comes in. Somebody else might have this question anyway. The student's ID comes in. It's paired with a team. And along with that, for that particular pairing, we check off whether or not that person is a lead. Which the only thing is to make sure that you understand that every week we're incrementing those team IDs, right? Because we're never going to reuse the same team IDs from one week to the next week, unless we had the same team, right? Because the teams are constantly changing. So over the course of the semester, we'll have 40 different team IDs or however many we need for that on that. And so if we are then going to do a query, as far as the fact table goes, we can easily find out what's the average team score, how are team scores changing by date, what types of analytics assignments give us higher or lower team scores, right? All of those things. If we want to know what are the scores for an individual student, then because we're linking through the team dimension, we'll grab that student's team score, but we'll make an adjustment. So we have to have a business rule that tells us that we have to make an adjustment based on the yes or no for those particular attributes that we have here. So that is a way that we can use a bridge table, have attributes of the bridge table, and be able to do this. Now, I need to show you one more thing, and then we'll be finished, just a couple minutes more. What if you had the situation where you gave a bonus, but you were able to give the bonus to more than one student, and the students were splitting the bonus? Actually, this is not a good example. Okay, let's not use that example. So that's not illustrating what I want to illustrate. So I'm going to go back to my PowerPoints for one more second here. Okay. Mm-hmm.
How would we handle disaster? How would we handle the students not having been in the same team?
No, that's because the next week they are the team switch, right? So a new team key for the next week. Okay, so if we look at this slide one more time here with the sales reps, you can see that there's, in our order fact table, there's a certain number of dollars for that order. So let's say it was $44,000 on that. But we want to figure out what are the sales by sales rep. So if we create a report that has each sales rep and all of their sales, and we say that, oh yes, each sales rep got that $4,000, what are we doing? We're duplicating that for each salesperson that participated. We're duplicating the amounts, so the total amount at the bottom of our report is going to be wrong, because we're going to overcount, we're going to double count what that was sold for. So the allocation underneath that sales group would be 0.5. If you had, let's say, 2 people, or if you had 3 people sharing the sale, it could be 0.33. You could make it whatever fraction you wanted, so that when you calculated the sales of that salesperson, you could give them only a portion of the sales. And so the total sales would add up properly. So what I was thinking with the team lead is, what happened if I would give a whole team, 400 points for the 4 people, but then some people might get more than 100 and other people get less than 100. That would be an allocation as well. So this is called an allocation, where we want to take that total amount of the order dollars and divide it up amongst all of the people. In our Professor Cathaway's example, we're not dividing up the scores because everybody on the team gets the full amount of the score. So that's why we did not need an allocation for that problem. So this is called an allocation. And so that's the last thing that I have there. So any last question? So I'm glad you all participated here at the end. I hope this was a little bit less tedious to just have an in-class exercise. And I say we'll try to have more of them and spread things out a little bit more. So thank you for your good attention. Thank you for your participation. And we'll see you next week.